All right, everybody, let's wrap up our discussion of the paired samples t-test in the context of hypothesis testing. Okay, so we have our general question: does taking a study pill improve your test scores? And our research question is the test 1 average without the pill significantly lower than the test 2 average with the pill? We have our same 7 steps. Calculation of the t-score slightly different, but the same 7 steps are exactly the same as they were with the other 2 t-tests. So step 1 is our variables. We already identified this. We have our categorical independent variable, which is taking the pill. 2 groups are the one without the pill, the one with the pill. And then our measurement, our calculation, our average is for the dependent variable is test scores, which is continuous, and it ranges on a scale of 0 to 10. So we want to know, is there a difference between the average test scores compared without the pill compared to with the pill? Now we have our hypotheses. This is what it would be phrased like if it was non-directional there. So it's just like it was with the independent samples t-test. You have non-directional hypotheses here if that was the case. But our question is directional. Is the test 1 average without the pill significantly lower than the test 2 average with the pill? So it's directional. Right, so the test 1 average without the pill is significantly lower than the test 2 average with the pill, meaning that X bar is lower than Y bar. Okay, because the alternative says yes to the question, and the null is going to say the other direction and equal to. The test 1 average without the pill is significantly higher than or equal to the test 2 average with the pill. X bar will be greater than or equal to Y bar. All right, so those are our hypotheses. So let's put this together. So we have 4 students in a study, and they are studying the effectiveness of a cognitive enhancement drug. Okay, so students take the pill and they take a test. Then a week later, they take the test without taking the pill. Again, that's a typo. Sorry about that. So you have your research question: is the test 1 average without the pill significantly lower from the test 2 average with the pill? We have our variables here: independent and dependent variable. We have our hypotheses, just shortened for the sake of space. All right, the alternative says that X bar will be lower than Y bar, and the null says X bar will be greater than or equal to Y bar. Then we calculate our t-score, which we already did here, so we have -7. And the question we have to answer is, how likely were we to find this difference between the average test scores without and with the pill? So how likely were we to find this? Was it likely that we'd find this assuming that test 1 would be greater than or equal to test 2? Or was this unlikely to find, assuming that? Okay. So if the probability of t is less than 0.05, then finding this difference would be unlikely. Okay. So the way we do this is we find a critical score, the same way that you're going to find the t-crit, just like you did in the previous t-test. And if the t-score goes past the t-crit, it is a probability less than 0.05. If it's before the t-crit, probability greater than 0.05. Just like with the independent samples t-test, we talked about this, and with the 1 sample t-test, if you have a 2-tailed hypothesis, 2-tailed test, the crit score goes on both tails. If it's 1-tailed, then it goes on one of the tails, and that's determined by whatever the alternative hypothesis says. Now, in the independent samples t-test, the degrees of freedom is n-1, just like with the 1 sample t-test, but here n equals the number of pairs, not simply the sample size. So it's the number of pairs in both groups. Let's say that somebody dropped out the second time around, right? 4 students took the test, but only 3 came back to take it the second time. Well, then n would only be 3 because you have an incomplete pair. That 4th student who didn't come back the second time, he or she gets thrown out of the data set. N is the number of complete pairs that you have. So you take that number -1 to find your degrees of freedom. So find the critical score for this scenario. Alpha is 0.05, 1-tailed test, n number of pairs is 4. You take 4 minus 1, and then you have to determine if it's going to be a positive or negative, since we're working with 1-tailed hypotheses here. Now, the critical score you should have found is -2.353. Okay, it's negative, so it's going to go on the negative side because our alternative hypothesis says X bar is less than Y bar. So when it says less than in the alternative, the crit score goes on the negative side. So does our calculated t-score Does it go past the crit score or is it before the crit score? It goes past the crit score, right? -7 goes past -2.353, which means that it has a probability less than 0.05. So it was unlikely for us to find this, difference. It was unlikely to find this, assuming that test 1 should have been greater or equal to y bar. Okay, so that is evidence against the null. So we reject it, we accept the alternative as our conclusion. That becomes our research conclusion. The test 1 average without the pill is significantly lower than the test 2 average with the pill. So put it back into the general phrasing, just like the general question. So the general question was, does the, let's take a look at that real quick. Does taking a study pill improve your test scores? So yes, taking a study pill improves your test scores because the test 1 average without the pill was lower than the test 2 average with the pill, okay? So that's our general conclusion. And lastly, we can also use a bar graph to represent this, okay? We see the test average without the pill, the test average with the pill. You can clearly see from this bar graph that with the pill has a higher test average than without the pill. And that difference seems to be large. So that would indicate that maybe this difference is big enough that it might be statistically significant. So visually, that's what that shows us here. And that is how you do the paired samples t-test with hypothesis testing.